Hi guys, welcome back to Dharma Geosphere. Today I'll be starting the video series on geomorphology, section 1 on the fundamentals of the physical geography. So geomorphology is one of the most interesting topics in the physical geography part. You can draw a lot of diagrams and the concepts are clear, you can really write very well. So I'll start off with the most important topic in geomorphology, that is the slope development, and we'll do the best 10 models on slope development, and we'll cover what is slope actually, how it is defined, what do you understand by it, what are the various elements in the slope, what are the various factors which control the form and development of slope. That is climate, you have the rock structure, you also have the nature of the regolith, and then also how vegetation controls the slope, etc. And then the 10 models, modeled by starting from Fisher, the most important model, then coming to the very well known Davis and Pengs, and then Lehman, then you have Woods, then you have Strahler, another very important model, then you have Savigay, they have King, and then you have Hacks, and then finally Young, and then we'll see how White and all that, the new books that have come up in the slope development. So I will briefly tell you the catchword or the essence of each of the model, and then I'll explain you in detail on my slideshow. The first was Fisher's model. He said all the straight and vertical surfaces bounded by horizontal surfaces, the weathered material and the eroded material gets removed and gets accumulated as scree. Scree and talus is something which you should have by now understood what it is through the NCERT and other fundamental books. Scree is a finer material, talus is more angular and a larger material, the product of weathering and transportation and erosion, which falls and remains along the sea, the mountain bases or the hill slopes. Then coming to Davis, you all know that it was through 3 stages of evolution: youth, maturity and old age. According to him, there is a convex slope at the youth stage, a rectilinear slope at the maturity stage, and a concave slope at the old age. Similarly, Pengs, the difference between Davis and Pengs is that Davis believed that the erosion and the effects of erosion start only after the uplift has been completed. But Pengs believes that they happen in simultaneously. Obviously, in nature, things happen simultaneously. Erosion doesn't wait for the upliftment to take place and then start eroding. So they do happen simultaneously, so does the transportation. So Pengs believed that whenever the rates of upliftment are more than the denudation, it results in a convex slope, and if the denudation and the uplift rates are more or less the same, then it results in a rectilinear slope, and if it is only denudation without any uplift, it results in a concave shape. So that was Pengs. Coming to Lehman, he introduced the differential rates of weathering at each stage, and he said the convex boundaries remain intact and are protected from weathering if it is covered with this scree. But if it gets exposed, it gets retreated, and then it forms parallel, or it could be even a declining retreat. So that is what was Lehman's concept. And then came Wood. He said changes in, he brought in the concept of transport. He said changes in active transport through sorting. If there is more sorting, yeah, there is more finer material which go a much longer distance. If it is less sorting, it is more angular material and it travels less. And then came Stoller. Stoller was one of the most important biomorphologists. It's also a beautiful book of very beautiful diagrams, very impressive, very aesthetically drawn diagrams and pictures you will find in his book of physical geography. So according to him, he said that the bare slope will get weathered and eroded much faster than the slope which has vegetation. And then came Saviger. He brought in the concepts of a parallel retreat and a rectilinear slope, how they can happen simultaneously due to denudation and the effects of weathering and transportation. And then came King. He was really king when it came to slope because he studied quite a lot directly in the field, and he brought in the field observations. Then he according to him, the slopes retrieve backwards extensively and they result in a very large plain which he termed as the peδιplain. You will understand what is pediplanation, etc. And then Hack brought in the balance between uplift and erosion, and he said that the slopes increase in the direction of their inclination because of increased transportation. And then came Young. He brought in that both parallel retreat slopes and the declining retreat slopes can form simultaneously at the same time and can be seen in the development or in the place of slope. So among all these 10 models, one thing that is most striking and is almost mostly neglected in many of these institutes and even in books is the Fisher's model. Fisher's model opened up the subject of slope development, and in fact his theory brought in two very important elements, that the geomorphic processes, that is the landscape, and the elements of landscape, that is the slopes, which are the most important elements of any landscape, can actually be studied quantitatively, they can be quantified, and their results can be tested through the field measurements, etc. So this opened up a lot of focus and importance of the study of slopes. The other important thing is through the geometries being made through quantitative methods, you can study these slopes in qualitative way. So the qualitative studies also started after the Fisher's model. So now guys, after these 10 models are what I think are the most important, and you should remember what each is. More importantly, you should remember and draw the diagrams. In geomorphology, the diagram will fetch you marks, and also try to read books which I'll suggest, and see those actual pictures, so fascinating, and then try to read those captions with passion and bring in your heart. Geomorphology is very interesting. So now I'll show you some slides. So let us understand in more details about the slope development. Slope is any inclined portion of the solid surface of the earth, but you should define by quoting somebody who has whose definition has stood the test of time, like say Strom. He said hill slopes may be defined as the surfaces between a drainage divide and a valley floor. Coming back home, it could also be said that the slope is an upward or a downward inclination of surface between hills and valleys and form most significant aspects of landscape assemblages. So basically trying to understand, they develop where weathering and the erosion are slow, as in arid regions, and where the rock resistance is high. So you have rock which is highly resistant and a rock which is say less resistant. the resistant rock offers a free surface, and then it becomes a drainage duet, giving rise to a convex slope when weathering occurs. So this is a comparison of an idealized profile for weathering limited faceted hill slopes, you can see on the left, and transport limited sigmoid hill slopes on the right. And if you want to see how an example of a slope in an arid region in Africa, this is how it looks. So slopes can be of two types: primary slopes and secondary slope. Primary slopes are formed by processes that tend to promote relief, that is uplift, and secondary slopes are formed by processes tending to decrease the relief. Secondary slopes generally evolve from erosion and modification of the existing primary slopes. So coming to the factors changing slope, which can be divided into endogenic and exogenic. Endogenic are the tectonic forces which cause vertical irregularity and lead to slope evolution, whereas the exogenic or denudation forces cause leveling of the surface, leading to slope development. So as far as the UPSC syllabus is concerned, the topic given is slope development, that is only exogenic or denudation forces we have to understand. Slope evolution is not part of the syllabus, so don't get confused there. So when you are writing about the exogenic and endogenic features, it's better to draw a diagram like this and show the exogenic and endogenic forces diagrammatically. It gives a much aesthetic appeal instead of just simply writing it in a routinized way. And then slope elements, this I am sure you would have studied even while preparing for the prelims. It has a summit convexity, there is a free space, and this is then there is an rectilinear, and then this is base concavity. Basically the deviation cycle of erosion. So here in the real picture you can see crest, cliff, talus, and the pediment. The king also divided these into four. One is the waxing slope, this is the waxing slope, this is the free space, this is the concave, and this is the waning slope. And we can put all these slope elements also in an idealized diagram showing the crest as the waxing slope formed by weathering and creep, and then you can show the scarp, which is the free face, and formed by the landslides, or it could also be rill wash. And the debris slope that is the constant slope or the rectilinear slope, which comprises detritus from the scrap, and then the waning slope, which is the extensive plain land, which King termed as pediment and pedimentation. So similarly, there are segments in the slope. There are three segments: the convex slope, concave slope, and rectilinear. All three of them actually you can show in one diagram like this. You can see the convex slope, the concave slope, and in the middle is the rectilinear slope. And then you can write down all the important parts of the convex slope and the concave slope, that is the interflow, seepage slope, convex creep slope, the fall face, and then the transportational mid slope, then the colluvial foot slope, the alluvial toe slope, and the channel wall and the channel bed. Each of this also I have described in the next thing. So try to bring in beautiful diagrams and all that instead of writing the same routinized nodes and draft kind of diagrams, some Savinder Singh and all that. Those have become now old. Try to bring in a little more dynamism. There are a lot of books on slope development. It's a very important subject because without slope there is no landfall. Everything starts from a slope. So this is the description of each of those which I have outlined, and then this is the convex slope, how it is formed, as you can see it, and this is the concave slope. The concave slope, and between the concave slope and the convex slope you have the key point which differentiate them, and then this is the rectilinear slope. That is more or less the linear slope. Then examples you can take the Bandar Plateau. This is the beautiful Bandar Plateau where you can see all the four elements more or less happening at the same time within the hill ranges in the various hills. This is the diagram drawn from the picture. And then what are the factors controlling slope form and development? Obviously climate, arid regions have different kinds of slope. Moist, humid regions will have different kinds of slopes. So the geological structure controls it, and then the nature of regolith also is very important. The soil conditions, vegetation is another very important aspects. All these four I have given the details how each of these climate regions have their slope, because based on the climate is the soil profile, and based on the soil profile is the weathering, and based on the weathering and the erosion, based on the erosion you have the slope. So if you see schematically, you can show the combination of how temperature, precipitation and slope that dictate the occurrence of a bedrock and soil mantle terrain. It's a three-dimensional pic. You can draw temperature on one side, precipitation on one side, move it from arid to wet and wet to low warm. Then it looks a little more beautiful and more captivating instead of simply going on writing. So this is a typical slope in semi-arid region. You can see the free face or the cliff is almost vertical in semi-arid regions, and the debris slope is much inclined, leading to rectilinear slope. And the humid temperate regions, you can find a typical Daviesian cycle of profile starting from convex to rectilinear to leading to concave. Then the geological structure is very important, particularly what kind of rocks are there. If you have metamorphic rocks, they weather less, and so are the igneous rocks. But if you have sedimentary rocks, they weather much faster and they get eroded much faster. They are also transported, so it gives a very totally different kind of slope. So here is a small model of relative stability of slope as a function of orientation of weakness, that is based on the rock structure. This is one is the most stable, where you find the metamorphics or bedding or igneous rocks. The moderately stable is the one which is here. Basically here the sedimentary rocks get eroded very fast because they are softer rocks. So you can see the difference in the stability of slopes based on the kind of rock surface it is. And then nature of the regolith, which includes soil, scree and weathered bedrock. This also impacts the way the rocks impact. You can see the runoff with saturated soils. If it is sand, it is much less. If it is silt, it is much more, and if it is clay, it is much more. And this is how what the regolith results. And the more runoff, the more steeper are the slopes. And vegetation is another very important because it can decrease overland runoff. It can, and then there is no vegetation. It means there are fewer trees, and the runoff is much faster. Then coming to the models of slope development, I have given you in brief. Now a little detail you can go. The Fisher's model is the most important model because it's the first geometric model that predicted the evolution of a vertical bedrock quarry phase in southern England. It showed that the quarry phase, which is vertical and bounded by horizontal surfaces, and any material that is weathered would accumulate as scree. Scree is nothing but softer material. I'll show you in the picture what scree is. And then this highlighted and got into two very important aspects. As I said, that it provided an example that geomorphic process can be mathematically explained, And the second was a simple geometrical argument produced realistic slope geometries that influence qualitative studies of hill slope development. So it opened up the studies of slope development. Daviesian theory is simple, as I have said. It forms the youth stage is convex, the maturity stage is rectilinear, and it goes on to the old age peneplane where it becomes concave. So this is youth convex, mature rectilinear, and old is concave. You can see here. Then Pengs theory, Pengs focused on the tectonic process. The difference between Peng and Davis is that Peng believed that both upliftment and denudation occur together or occur simultaneously, whereas Davis thought that first uplift occurs only after uplift erosion starts, which is unlikely in nature. So this is what is Peng's model. It is a very simple model wherein he said that they get replaced when uplift exceeds denudation. You have a convex surface. When both the denudation and uplift are acting together or simultaneously, the rates are the same. You get more or less a rectilinear slope. But if there is only denudation and there is no uplift, you get a concave slope. So these are the various steps of the Pengs cycle of erosion, or his model of development of slope. It finally gets into a concave slope, as I've shown you in 4 steps. So this is an example of the slope retreat, and this is Utah. And then you also have Bryce Canyon, where you can see again in Utah how the slope gets retreated after the denudation has happened. This is another important model, Lehman's model. It's also called as Fisher-Lehman's model because it's basically a kind of a supplement to that. Here he introduced the element of different weathering rates. But here is one person who actually went to the field, collected samples, did extensive research, and then came back with his results, wherein he showed that the intact rock surface is protected from further weathering, but if the rock surface is exposed, it continues to weather and then start retreating. It forms parallel retreat, it forms waning retreats. So as I was telling you earlier, I will show you what this is. Scree. This is the smaller rock fragments which have been laid on the slopes of beneath the slopes after weathering and erosion. Generally they occur along the mountain cliffs where you can see. Then Woods came with another important concept of bringing in the element of transport. He said that the more the waning slope forms because of the size sorting happening in transport that occurs, and where finer material is carried away further from the main slope as this transportation or the sorting increases. So this is talus. The difference between scree and talus is the talus here, as you can see, these are much angular, much larger fragments falling at the cliff or the hill slope or at the base of the hill. There's talus. Talus is one, they could actually ask, put a short note on Starler's concept of slope. This you should pay attention because Starler is a big guy. He wrote a lot of books on physical geography and also on the geomorphology. He's working in various parts of California. But most important of his is he said that the base slope would contribute greater amount of load than a vegetated slope at a given angle. This will result in steeper channel gradient beneath the base slope than that of the vegetated slope. In fact, this concept actually revolutionized, and then people started working on, and there were several studies on vegetated land slope, particularly relating to how the soil affects the slope and how the slopes in turn affect the soil. So he made some very careful measurements of slope. He discovered that where the river was closer to the foot of the slope, it formed a steeper slope because of the removal of the debris by the river. So the same concepts were used again by King and others, wherein they studied the sea coast and found how the waves of the sea control and contribute to the different slope development. But when the stream was away from the slopes, they were protected from the basal cutting and had much lower angles. Stoddard also argued that there could be an equilibrium reached. This was again strengthened by the work of Hack and later on Young. Then Savige, he said that the development related to the deposition of weathered material at a slope base. So his basic argument was he did a lot of work in the Carmarthen Bay in the South Wales. Beautiful. I also happened to visit that, of course, not with this purpose because my son stays very close by. The materials coming at the base of the free space are instantly removed by the sea waves. As I said, like how Stoddard said that the river action, here it is the sea action which removes it, and that the basal free space slope is maintained, but it experiences parallel retreat and upper limited summital convex element. I'll show you the Carmarthen Bay. So these are the two types of slopes that can result because of the wave action. One could be a broader summit convexity and one with a limited summit convexity. So this is the beautiful Carmarthen Bay wherein you can see the various kinds of slopes, how you see that beautiful rectilinear slope as well. Then coming to King's model of parallel slope retreat is very well known. What he basically said here was similar to what the daily cycle of erosion, but instead of penny plane, he used the word pediplane. Here he showed how the parallel slope retreat allowing for lateral translation of slope forms and the persistence of wide pediments and Inselberg of sustained relief. These Inselberg and PD planes which you are seeing here are small outbound mountainous structures or hills which actually with the passage of time coalesce together and form a very large plain, which King termed it as a pediplane or the process of pediplanation. So this is the parallel retreat. This is how it happens, one after the other. First the scarp is formed, then the pediment, and later on the pediplane. But pediplane is just not one plane. There are many pediments which coalesce together and form a large pediplane. This is the diagram you can show for the pediplanation. And then Hack's model of steady state, here he believed that there is some kind of an equilibrium maintained by the balance between uplift and erosion. He worked extensively on the Appalachian Mountains in USA. He suggested that landscape tend toward a balance between uplift and erosion, implying that they are independent of time. So these are the slopes in the Appalachian Mountains, USA. Here is what he shows that the process of uplift and erosion eventually reach equilibrium irrespective of the time period. So here he has shown the two graphs, the steady states wherein it takes years of decades of deposition and erosion and to reach the equilibrium, and then the dynamic equilibrium which reached over millions of years, that is the geological period. So this is basically what again he shows us in the model, the three stages of dynamic equilibrium. Then the Young's response model, here this is the last model which I thought is the important one, the distinction made between slope transport and direct removal. He brings in two concepts as a parallel retreat and declining retreat. The parallel retreat happens because of quasi-continuous downhill movement of the slope mantle, whereas the declining retreat happens because of equal transport of the slope mantle across the profile. So one is related to the downhill movement of the debris on the slope, the other is because of the added transport. So you can see both the declining retreat and the parallel retreat. Parallel retreat happens only because of downward movement of debris along the slope, whereas the declining retreat happens because of the added transport element. So this is how it can also be shown by the direct removal, suspension and the chemical solution by groundwater, etc. how a dynamic equilibrium of the process is reached. So this is an important book of Carson and Kirby, 1972. Some of the slides and the important material I have picked from this. Just go through the book in an electronic form if you have, and also try to read the important paper by White on the hill slope morphological development on a landscape scale. Here he tries to find the difference on the large slopes and small slopes, if there is any shape behavior or they behave similarly, or is there some underlying size constraint which elicits different reactions merely because of the form magnitude. So this problem he addresses based on the studies, various studies by White. He concluded that slopes of different height, length or steepness as well as those developed on different parent material all possesses equivalent form elements, that is convex, rectilinear or straight and concave segments. Thus, the geometric parameters characterizing the gross morphology of small slopes are identical with those of large slopes, although the numerical values describing the form elements may necessarily differ. Okay guys, that is all about White and Carson and Kirby. These are some important documents. I have a lot of supplemental material on the slope development, but whatever I have given you here should suffice as far as the topic of slope development is concerned. If you want a PPT or a PDF of this, please send me a request on WhatsApp. You need not join any course. I have no commercial interest or anything. I just want to help because it's my passion, and particularly geomorphology is my favorite subject. That is also my background. I am an earth scientist. I have seen many of these landforms in their pristine forms, and it's a very, very interesting subject. Develop that passion for geomorphology. All the topics in geomorphology are very interesting. I hope the same syllabus continues in 2021 and 2022. Let's see, but even then all these topics are very, very important. Okay guys, all the best. We'll catch up with another very interesting geomorphology topic in my next video. Thanks a lot, and thanks a lot for all the support and your WhatsApp messages and emails, which keeps me going. I'll bring in my best. Bye.